So in this video, we're going to learn something pretty neat about this perpendicular bisector construction. If you remember the perpendicular bisector construction, what you're doing is you're taking your compass and putting it at one end of the segment and opening up some distance, probably more than halfway. And then we're going to make an arc. And the thing to remember is that this arc represents a set of points that are all the same distance from this endpoint. And if I go over onto this side, and let's flip this compass around, and let's even change the color on it too, make it red, that this red arc represents all the points that are the same distance from this right side endpoint. These endpoints need some letters on them. Let's call it point A over there, and let's call it point B over there. There we go. So the red arc are all points the same distance from B. The blue arc is all the same distance from A. And you know that when you do your perpendicular bisector now, what you do is you take these 2 points and you join them together. And I'll make it a little bit longer so it's more like a line going through them. So this line that I've constructed here is the perpendicular bisector of segment AB. But something really cool happened. And again, we'll just want to highlight what it means to be on this red arc. If you're on the red arc, you're the same distance from point B. If you're on the blue arc, you're the same distance from point A. So what happens if you're at this green point here that we call point P? Or this green point down here that we call point Q? Well, because P is on the blue arc and P is also on the red arc, it's the same distance from A as it is from B. We use this phrase equidistant. And the same can be said of Q and its distance from A to B. And it's also true about any point on this perpendicular bisector. Let's put this point up here, and let's call it point R. So if we are going to draw a segment or measure from R to A and from R to B, it's the same distance. And that, my friends, leads us to, get ready, here it comes, a conjecture. So if a point is equidistant from the endpoints of a segment, it's on the perpendicular bisector of that segment. P-E-R-P-E-N-D-I-C-U-L-A-R, bisector. Cool. If a point is equidistant from the endpoints of a segment, it is on the perpendicular bisector. That was like points P and Q. Because if we go back real quick, we made sure that point P and point Q were the same distance from points A and B. So that's where we get our conjecture from. We made sure that those points were equidistant from the endpoints. It's on the perpendicular bisector. Now the next part is the converse true? The converse is when you switch the order around, meaning that if we start with a point on the perpendicular bisector, is it equidistant from the endpoints? And that's where you're talking about with this point R. Point R is on the perpendicular bisector. So the distance from R to A is the same as the distance from R to B. So the converse is true. We'll drag that baby out there. So if a point is on the perpendicular bisector, it is equidistant from the endpoints. So this is a really nice relationship. And it's like an if and only. What I mean by that is, as long as one part is true, the other part's true. If you know that a point is the same distance from the endpoints, it's on the perpendicular bisector. That's the top one. And if you know that a point's on the perpendicular bisector, it's equidistant from the endpoints.